Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we are going to be talking about hypothesis testing. This is the first video on hypothesis testing, and this video is part of our course on econometrics, right? So let's go ahead and get started, right? So this is the first video on hypothesis testing. So I'm going to be touching the very basics of hypothesis testing. So if you already know what hypothesis testing is, so you can skip this video. Otherwise, if you're starting your journey for hypothesis testing, this is the right place to start, right? So what exactly is hypothesis testing, right? So hypothesis testing determines what we can learn about the real world from a particular sample. So what exactly happens is that you have a certain population, right? So let's say this is your population, right? And let's say, for example, I'm trying to study the effect of the effect of education on wages. So what I'm trying to do is I'm trying to study the effect of wages on education. How does education affect wages, right? So this is what I want to do, right? And I have a population, and that population, let's say I'm trying to study the effect of education on wages, let's say in United States, right? So this is what I'm doing. So my population is United States. But there is a problem. The problem is that I cannot collect data about every person from United States, right? So the thing is, even though if I'll be able to collect data, it's very, very costly, right? It will take billions of dollars to collect this kind of data because how do I know it'll take billions of dollars? Because the census takes easily 10 to 20 billion dollars or 10 to 15 billion dollars for collection of data, and the collection of data, the analysis of data, and everything. So it will be very, very costly for me to collect that kind of data. So what can I do? So what I can do is I can actually take a sample of people from United States, right? So there are certain properties of sample. There are certain properties that this sample should hold. Well, we'll talk about this. This is a discussion of a completely different time. Well, so what we do is we actually collect a sample, and then we try to see what is the effect of education on wages in this particular sample, right? So if do we find the effect of a positive relationship between education and wages in this sample, or we find a negative relationship, or we find no relationship, right? So hypothesis testing determines what can we learn about this population from this sample. That is what hypothesis testing does, right? So most of the studies that you go online, you learn that in this particular study, let's say XYZ food is connected, is linked to cancer. Again, those studies are all related to hypothesis testing. And even if you go and get a medical test done, you get an MRI done, or let's say it's not an MRI, you get any test done where it will tell you whether you have the particular disease or not. That is all hypothesis testing. So this is what hypothesis testing is. It tells you what can you infer about the real world from a particular sample. Now, so you want to know that, let's say I got a positive relationship of education on wages. Let's say I got a positive relationship. I want to know whether that positive relationship could have been obtained by chance. Was that related to chance, or is a positive relationship between education and wages, right? So this is something that I want to know, right? I want to know whether this applies to the real world or not, right? So hypothesis testing tells you that. Another thing is, can our theories be rejected using the results generated by our sample? Again, that's the same story which the second point is saying. If, let's suppose, I do not get expected result in this sample, can I just reject the theory? Can I say that education doesn't affect wages, right? So this is, again, hypothesis testing helps you in answering these questions, right? Another thing is, let's say a theory is correct, right? Let's say a theory is correct. What is the probability that this particular sample would have been observed, right? So this is another question which hypothesis testing will actually answer for you, right? So that's there, right? So what exactly is our approach when we do hypothesis testing, or what exactly is our approach in econometrics, or possibly in this playlist? So our approach is it's of a classic approach. We are following a very classical approach. What is that classical approach? We assume that the sample data are our best and only information about our population. That is something that we assume, right? We're not following the other approach, which is a Bayesian statistics. We're not following that, in which sampling distribution, doesn't matter that much, right? So here we are assuming, this is the assumption that we're making, that the sample that we have is a true representative of the population, right? Well, most of the times, or some of the times, it might not be a true representation, right? But there are problems to deal with this kind of scenario that we'll discuss later when we do some when we do some more videos. But right now, what we're doing is we're assuming that a sample best represents the population, right? So that's there. That is our approach, right? So let's get started, right? So let's say, for example, I'm going to give you a very basic example of hypothesis testing. Let's say you make a new drug, right? You have made this new drug, and this is based on some theory, right? So this new drug is actually based on some theory. The theory is that chemical X will actually eliminate disease Y, right? So chemical X, if taken in certain proportion, will actually eradicate, or maybe eradicate you of disease Y. It will actually heal you from disease Y, right? So that is your theory. This right here is your theory, and you have a new drug for that. Now, what you want to do is, before you start selling that drug, what do you want to do? You want to test this theory out. You want to test this drug out into the market, or on some sample of people, right? So you test it on a particular sample. You get some human subjects and you test it on them, right? So that's a whole different story. How do you get the subjects, and how do you make your sample? That's a complete different story. Let's say you get a sample. You're able to make a sample, and let's assume that that sample is true representation of your population, right? So let's say you get a sample. You get right amount of heterogeneity in terms of gender, in terms of genetic distribution. Let's say that all happens magically, right? Now you test it on a sample and you get some results, right? The results were that there are some side effects of this new drug. It might be possibly linked to cancer, or it might be possibly linked to some headache, or anything, right? So there are possible side effects that you actually got from this particular sample. So these are your results. Now you want to know whether these side effects are actually linked to the drug or not, and this is something that you want to know, right? And these are the side effects that you expected when you in fact started your study. So were these side effects expected, or were these side effects not expected, right? So usually, most of the times, not most of the times, all the times, you are going to lay down the results that you expect, right? This is something that you're going to do. You're going to lay down, okay, this is what I expect this by doing this particular experiment, or by this is what I expect from this particular data, right? Because if we try to generate results after doing our testing, or after observing the data, we are likely to generate results based on what the data is telling us, and that is a wrong approach. We will always lay down the results that we expect in the beginning, right? So this could possibly be, these side effects could possibly be by complete chance, right? It could be by complete chance that the characteristic of the sample was in such a way that it just belonged to this particular sample, or it could be that the drug is not good enough. So if your sample is a true representation of your population, then there is a very high probability that this drug is not good enough, right? So this is kind of an intuitive idea that what you do, you actually lay down your theory, you lay down what you expect, you test it on a sample, you get your results, and then you test whether these results are significant or not. This is what you test. If the results are significant, that means drug is not good enough, and otherwise it might have happened by chance, right? So we have a theory, right? So let's say we have a theory. The theory is education leads to high wages. I'm sticking to the same example that I gave in the first slide, right? We can never prove this theory. We can never say that yes, education leads to high wages. We can always disprove it. That is what hypothesis testing does. It will always disprove, it will always attempt to disprove your theory rather than prove it, right? So the more results we generate, the more studies that will give you the result that education leads to high wages, the more confirmed or the more confident you'll feel that yes, education leads to high wages. But you can never say with 100% certainty that education leads to high wages. This is something that you cannot say, right? So all that can be done is to state that a particular sample conforms to a particular hypothesis. So all that you can say is that yes, for this particular sample, education leads to better education leads to high wages, right? So this is something that you can say. You cannot say that this will be 100% true for the whole population, right? So if you can't prove something, why do we do hypothesis testing, right? So that's a question that arises in everyone's mind when they first start with hypothesis testing. Well, we can always reject a given hypothesis, right? So what we can do is, let's say you have a sample, right? So you have a sample and you want to say, you know what, I want to find out, does education lead to better wages, right? And you find that there is no such relationship. So what you've done, you've actually disproved something. So disproving something, it's what the major objective of hypothesis testing is. And whenever you disprove something, you don't disprove something with 100% confidence. There's always a chance of some errors, right? There's always a chance for some errors. What if that particular sample was not the right representative? Or even if it was a right representative, there is still a chance of you to make an error. And that chance is called level of significance, right? So we denote that percentage error to be level of significance. You can say that I can say it with 95% confidence. So usually whenever you state a theory or whenever you prove a hypothesis, usually we use 95% level of significance, or we use 90% level of significance, or if we are too sure, we use 99% level of significance. So what do you mean by this 95%? That with 95% confidence, I can say that education does not lead to high wages. So this is what the meaning of this word is. Right now, it's just a word. Later on, it's going to turn into something mathematical. We will see that when that happens, right? So this is what you can do with hypothesis testing. You can reject an hypothesis, right? So what is your first step as a researcher, right? So what exactly is your first step? So the first step is to state the hypothesis. You will never do a study wherein you will do a study and then look at the results and then try to formulate your hypothesis. That is a wrong way to do your study. The right way of doing a study is you state your hypothesis first. You know what? My hypothesis is that I believe that education should lead to high wages, right? So that's what my hypothesis is. So education should lead to high wages, right? That's what my hypothesis is. And then I will go to the data and try and see whether this gets proven or whether this gets disproven. That's another story for another day, right? So you state the hypothesis first. Then, so that's what I want to say, that hypothesis developed after estimation run the risk of being justifications of particular results rather than test of validity of those results. So what I mean from this statement is that sometimes we try to get results. A researcher always sees the data in a way such that he would want his or her results to be proven true, right? So you see a data, you're expecting education to have high wages, and then you see the data, it disproves it, you say fine, okay, this data disproves it, but you haven't laid down the hypothesis yet. You look at the data and you say, okay, education doesn't lead to high wages. All right, my hypothesis is education doesn't lead to high wages. That should not be the way. You will state the hypothesis first and then you will look at your theory. So I think I have made this very, very clear that you state your hypothesis first and then you go to your data to analyze. So when I say hypothesis, what are different kinds of hypothesis, right? So the first thing that you should know is about null hypothesis. Now, what is null hypothesis? Null hypothesis is a statement of values that the researcher does not expect. This is something that you're trying to disprove. Usually that's the case, not 100% of the times, but mostly this is the case, that you will state your null hypothesis in such a way that this is something that you don't expect. My null hypothesis would be, I do not expect education to lead to high wages. This is something that I do not expect, and I attempt to disprove this hypothesis. Right? This is what I'm trying to do. I'm going to disprove this hypothesis that education will not lead to high wages. So in terms of notation, it is the notion of null hypothesis is you have an H and you have a subscript O, right? So that's what null hypothesis is. So example, let's say you expect a positive coefficient, right? So you're expecting a positive coefficient, which means you're not expecting a negative coefficient, isn't it? You're not expecting a negative coefficient. So let's suppose I'm expecting beta to be greater than 0. This is what I'm expecting. So my null hypothesis would be beta to be less than or equal to 0, right? So that's what my null hypothesis is going to be. This is going to be my null hypothesis because I'm expecting a positive relationship. So what should be my null hypothesis? It should be that my coefficient should be less than or equal to 0 because that's non-negative. Sorry, not negative. It's 0 and negative, right? So that is what it is. Now, usually null hypothesis carries the equal to sign, right? So usually null hypothesis carries the equal to sign. This is just a way of doing research because this is something that you're attempting to disprove, right? So that's there, right? So another thing is that we can never accept the null hypothesis. We either reject it or we fail to reject it, right? So this is very, very important. We will never accept the null hypothesis. So you can never say that this hypothesis is accepted. You will say, okay, was I able to reject it or was I not able to reject it? For example, let's say you are in a court case, so you're either pronounced guilty or you're either pronounced not guilty. You're never pronounced innocent. And that's what null hypothesis is. Either you reject it or you fail to reject it. You never accept it, right? As I said, hypothesis testing is all about disproving, and proving is something that you don't do here. Okay, all right. Now, once you have the null hypothesis, you have your alternative hypothesis. That what if null hypothesis gets rejected? Then what hypothesis are you gonna say that, this is something that I expect, right? So the alternative hypothesis is a statement of values that the researcher expects. So you're expecting the null hypothesis to get rejected, which means you're expecting the alternative hypothesis to get you never accept the alternative hypothesis. Well, usually people say that, but you say if null hypothesis gets rejected, then the light goes on to the alternative hypothesis, right? So the notion is HA, right? So example is you expect a positive coefficient, then the null hypothesis would be positive coefficient, right? Okay, all right. Now hypotheses can be two-sided or one-sided. There are two types of hypotheses: one-sided versus two-sided. Now this is something that has tricked me for some time when I was an undergrad student, but now it's pretty clear. So what exactly is one-sided versus two-sided? So if an alternate hypothesis has values only on one side of the null hypothesis, then it is one-sided. What do I mean by that? I mean to say is, let's suppose I have these two hypotheses, right? So this is one type of hypothesis, this is one type of hypothesis. Now in here, what is my null hypothesis? So my null hypothesis is that beta is, so if let's say this is the number line, beta is either greater than or equal to 0. So the null hypothesis is in this direction, and my alternative hypothesis is in this direction, that beta is actually less than 0. So my alternative hypothesis is in this direction. So my alternative hypothesis is in this direction, and my null hypothesis is in this direction. As you can see, my alternative hypothesis is in the opposite direction of null hypothesis, and it's only one-sided. So this over here is a one-sided test. Well, in here, you can see that if I say this is the number line, it says the null hypothesis is that beta is equal to 0. So that is the null hypothesis. Well, the alternative hypothesis is that beta is not equal to 0. So alternative hypothesis will go in this direction as well, and it will go in this direction as well. Because if beta is not equal to 0, it could be positive as well, and it could be negative as well. So this over here is a two-sided hypothesis. So if the alternative hypothesis is on both sides of the null hypothesis, because there can only be two sides, because it's a two-dimensional space, the number line is a two-dimensional space. You can have either on this side or on this side. That means it's two-sided. And here, if it's on one side, you have a one-sided test. Right? So that is the distinction between one-sided and two-sided hypotheses. Fine. So I hope you understood the beginning of the first video here, where I've just set up what hypothesis testing is, right? We're going to be coming up with more videos. We're going to be completing the course, everything about it, right? I completely guarantee you that, right? So thank you very much for watching this video, guys. I hope you understood it. And before we go away, just give us your valuable feedback at this email address, that is support@perfectscores.org, and make sure that you give us your valuable like on our Facebook page, that is facebook.com/perfectscores. Follow us on Twitter and Instagram, and make sure that you visit our website. You can either visit perfect-scores.com, or you can just visit this particular link, that is perfectscores.org, right? So you can visit perfect-scores.com. That's completely fine. So I'm gonna be completing this course on hypothesis testing, and I'm gonna be posting more videos. So right now we're doing the basic level. We're gonna reach to a very high level in econometrics pretty soon. So I hope you are understanding what I'm saying here. So thank you very much for watching this video, guys, and I'll see you in the next one.